3.2. So today's topic is domain and range. Domain and range. Okay. Just a refresher and a reminder, starting February 1st, absolutely no phones in any classrooms. Okay, no phones, no headphones. So you might want to get in that habit already. If I'm going to refresh on domain, what would you tell me domain is? What's a really quick definition for the domain? It's the x values, right? The set of all x values in a function. How about range? Okay, range is going to be the set of all y values in the function. One quick little rule here, when stating domain and range values, when stating domain and range values, always put numbers in order from least to greatest. Always put numbers in order from least to greatest. And then the second thing here is only list repeated numbers once. Only list repeated numbers one time. Okay. Least to greatest, little to big. Okay, so if we're talking about domain, that's going to be from left to right because it's the set of all x values and x is measured left to right. If I'm talking about range, that's going to be in order from bottom to top. Bottom to top. A lot of times we look at a picture and we want to go from the top to the bottom. But that's not how we list our range values. Range goes from bottom to top. Cool? Yes. Okay, so our first example, we're already jumping in really fast. It says find the domain of the following relation. Find the domain of the following relation. And so we've got this set of ordered pairs. By definition, that's what a relation is. It's a set of ordered pairs. 2, 10, 3, 10, 4, 20, 5, 30, and 6, 40. So my first question for you is it a function? Why? What, doesn't repeat? Okay, so it could have said find the domain of the following function. In fact, your textbook actually does say function. I just wanted to know if you could tell if it was a relation or a function. Say yes, it's both. Remember, all functions are relations. Not all relations are functions. But no x's repeat here. 2, 3, 4, 5, 6. So no repeaters. If I'm going to write the domain of this function, I'm going to list all my numbers in order from least to greatest. All my numbers? Only the x values. Only the x values. In order from least to greatest. And I only list repeated numbers once. Since there are no repeated numbers here, I just write down all the x values. Least to greatest, only list repeated numbers once. Question, if it had said find the range, just because I want to be able to do that, that would be all the y values. In order from least to greatest, so what would I have?
10, 20,
Good.
30, 40.
And I only list that 10 one time. I know it gets used twice. I see 2 of those. But if I'm talking about the range and I'm talking about how far does this function go from bottom to top, then I only am necessary to say it bottoms out at 10. I don't have to say it hits 10 twice. You understand that? Okay. Now, let me ask you this. You've seen this before. This is my domain. 2, 3, 4, 5, 6. Could I also have said the domain includes any values of x between 2 and 6? And I'm kind of setting you up here. Well, it looks like I've got 2 through 6 as options, right? But is my domain inclusive of any value between 2 and 6? No. For instance, 2.5 is not included in my set of numbers, right? If I were to graph this guy, I would have 2, 10, and I would have 3, 10, and 4, 20, and y'all can see where this is going, 530, 640, but notice that there are gaps between the values. Can you see those gaps? That's because this is a discrete data set. Discrete is the word. Discrete, and I usually tell kiddos discrete means dots. Discrete. It's not continuous data. Not continuous data. Okay. Not continuous data. So if I told you that the grades on that quiz that we took yesterday went from 55 to 100 in this classroom. 55 to 100 in this classroom. Okay? Does that mean that every single number in that range was represented?
No.
Does that mean somebody in here made a 55 and somebody in here made a 56 and somebody in... No, because it's called discrete data. It's not continuous. Okay? Versus if I said, today I am 34 years old. Today I'm 34 years old. At some point in my life, I was guaranteed to be 16. Why? How do you know that? Because it's continuous. Age is continuous. I don't just hop in sometimes on my birthday and then hop back out of my life. I'm continuously aging. Do you see what I'm saying? So I'm always some age between the actual birthday days. Okay? It's a continuous rate. Is that making sense? The difference between continuous data and discrete data? So if it's discrete, we'll be dealing with dots, and our domain values will look like this, single-digit numbers. Versus if it's a continuous, we would have like an interval. That's what this is called. Inequality notation or interval notation, which means X is all of the numbers between here and here and all the ones included. Cool? Difference? Understood? Okay. Everybody stand up. Everybody stand up. Y'all are sleepy today. Rise and shine. Move your hands. Move your hands. This is at Marcus. Marcus, wake up. Move your hands. Look, I'll pause. This is good for you. All right, example 2. Example 2. We've got a function here. And our function says f of x equals x squared minus 1. F of x equals x squared minus 1. And so my question for you first, right off the bat, is what kind of function is it? This is a toolkit function. This is one you got to know. What kind of function?
Quadratic.
Quadratic. This one is quadratic. What shape does it graph? A U. It's a U-shaped function. We call that a parabola. Parabola.
We'll have repeating x values.
No repeating x values, but repeating y values. Good. Y values are going to repeat. Okay, I'm going to have a y value of 0 here and here. I'm going to have a y value of maybe 4 here and here. Good. Why? Is it a function?
Yes.
Yes, it passes the, what's that test that we can do? The vertical line test, that little guy where if I run a vertical line anywhere on this function, it only crosses through one time, right? Okay, the question here, and you should be able to tell this without looking at the picture, but I think the picture's helpful. You, by now, can envision this is quadratic, right? I scooted it down one because that's what it says to do. It says x squared minus 1, which would shift it down. We'll talk more about that later on this semester, okay? But what you should be able to envision when I see a quadratic function, I know it's a u, right? So the question here is, what's the domain? Domain is going to read how far left to how far right does this function go. And so you need to think of the u, and you need to know that its branches grow and grow and grow and grow and grow. And is there ever any number that I cannot plug into this function and get an output? Is there a number, any number, that if I plugged it in, I would get undefined? No. I would get an output that doesn't work. Well, if I plugged in 0, what do I get? -1, right? So there's no restriction on this domain. There's no time that this domain is broken. So there are a couple of ways we write this. One is to say all real numbers. All real numbers, or infinity. Real numbers meaning not the complex ones, right? We learned about complex numbers. These are all real numbers. Any number works here. Another way to say that is this symbol right here. It's a double-barreled R. I use it a lot. It's an R with 2 sticks. Double-barreled R. Mason said, or infinity. So we could write it in what's called inequality notation, where we go from negative infinity. We say this is the set of x values, and x is less than the positive option, which would be positive infinity. Notice here that I did not put or equal to signs. Who can tell me why I did not put or equal to signs? Because it can't equal infinity. Okay. We also learned a notation called interval notation, and this is the direction we need to go most often. Interval notation means x lies on the interval from negative infinity to positive infinity, and we match these idea symbols where I didn't put or equal to with what kinds of symbols on here, on the end points of the negative infinity and positive infinity. Parentheses or square brackets. If it's not touching at that point, we use parentheses. So since this one did not include negative infinity and positive infinity, can't actually touch there, then we have parentheses on our brackets. Yeah? Everybody okay with that? Okay. What's the range of this function?
-1.
Ooh. Infinity. You see that those arrows are going up forever and ever? Can you see it? They're never going to stop. -1 to positive infinity. What kind of bracket do I have at -1? Square. And what kind on infinity? Parentheses. Another way to say this would be that inequality where I would say y is greater than or equal to -1. Y is everything bigger than -1. Says the same thing. Could I put all real numbers here? No. Yeah, because there are some values that I'm not going to output. Any questions on that? Okay. So a try it really quickly. A try it for this one. The question is, what is the domain if f of x is equal to x cubed minus x plus 5? First of all, what kind of function is it? Cubic. Good. Cubic. And now you're envisioning a cubic function. Those look like this. How far left to how far right? Infinity to infinity, so all real numbers. Negative infinity to positive infinity. In other words, if I'm looking at this function, there's no number that I'm going to input there and get an undefined answer. I'm not going to break it. Questions at all? That's good.
Hold on, don't go ahead.
Okay.
Is that, wait, what is that? Negative infinity to infinity?
Uh-huh. Negative infinity to infinity. And this is the domain. Spoiler alert, the range would be the same. Can you tell that it goes all the way down and all the way up? Your range would be negative infinity to positive infinity as well. Good, good? Okay. All right, so here's example 3. We have f of x equals x plus 1 divided by 2 minus x. X plus 1 divided by 2 minus x. So this is a function containing a fraction. Function containing a fraction. So that's a reciprocal function. Good. It's not a reciprocal squared function because there's no squared in the bottom. Okay. This is a reciprocal function. We also call these rational. Rational functions. Rational means fraction. Okay. And earlier in the school year, when we dealt with these rational functions, we solved them, we did all kinds of stuff with them. We had to state restrictions on the domain because there are rules when we're dividing. What's the rule when we're dividing? Cannot, what? Cannot divide by, what? Not variables. 0. I cannot divide by 0. That's the restriction. That is the restriction here. If I put 0 in the denominator and I try to divide by it, it breaks it. Undefined. So our domain is bound by that restriction. X can be any number except the number that puts 0 in this denominator. So how do I find that? In order to find what that value is going to be any number except what makes the denominator 0. So we set the denominator equal to 0 and solve for x. You with me? Can we do this before? What's the denominator? The bottom? The bottom cannot be 0. So we figure out what is x when the denominator is 0. It's a 2. So negative x equals negative 2. Divide by negative 1. X is 2. So my domain is x such that x does not equal 2. Do you all remember doing this before? You got nothing on breakfast this morning? Oh. Do y'all remember doing this? Anybody? X so that x is not 2. Because as long as x is not 2, this function has a value, an output. But if I input 2 into right there, in the bottom, what is 2 minus 2? 0. That is the domain. X so that x does not equal 2. Those are brackets. They're bad brackets. I'll do better.
I didn't know if they were just drawing squiggly lines.
Okay, so let's put it in interval notation, which is a lot more familiar to you. It can't be 2. It could be anything less than 2. So how do I put that? How far less than 2 could it be? Negative infinity? So let's say it like this. Negative infinity, wowzers. Negative infinity to 2. Can it be 2? 2 breaks it. So parentheses. Could it be bigger than 2? Any number bigger than 2. So we'll go from 2 to positive infinity. Do y'all remember that u? It's a u. It means union, including this set from 2 to positive infinity and from negative infinity to 2. This is maybe a better way for you to state the domain. X can be any number as long as it's not 2. Are we liking that better?
No. Well, no. I'm still lost. It doesn't matter.
Okay, so let's try another one. It does matter. It matters a lot, Mason.
Really?
Oh my goodness. All right, so here's your function. F of x is 1 plus 4x divided by 2x minus 1. This is another rational function. F of x equals 1 plus 4x divided by 2x minus 1. So to find the domain of a rational number or a rational function, to find the domain of a rational, that means fraction, of a rational function, comma, set the denominator equal to 0 and solve for x.
I got the eggs. Do you put the weird line?
You could. Let's set it up first. So what is my denominator?
Eggs. 2x minus 1.
Okay, so I'm going to set that 2x minus 1 equal to 0.
Plus 1.
Add 1.
Divide by 2.
2x equals 1. Divide by 2. X is 1/2. So x equals 1/2 is the value that breaks this function. It's the value that causes this function to be undefined. So my domain is actually everything except that number.
Yeah, so the eggs is the equal with the line.
So negative infinity to 0.5, and then the u-30.
Uh-huh. So I like it. Duncan is saying x is not equal to 1/2, which I agree with. But you're putting it in interval notation, Judson is. He's saying we could go from negative infinity all the way to 1/2, and then we have to pick up. We have to stop. And then we can start again at 1/2, and we can go all the way to positive infinity. Note that we're using parentheses at 1/2 because x is actually not allowed to be 1/2. It can get really, really close to 1/2, but it cannot be 1/2. Feeling better?
Fine.
Okay. Set the denominator equal to 0 and solve for x, but then you have to realize that x can't be that number, right? That's not the domain. It's everything except that value. Okay, let's try it on a new kind of function. Mason, did you get all of that?
How you find the range though?
The range, how do you find the range? That's a great question. They're typically not asking for the range on these, but what you would have to do is you would have to, it's a limit. You'd have to, it's way over your head.
I bet.
No, just, okay. Next year, pre-cal. You come to me in pre-cal. I will teach you how to do that. But you're coming to me in pre-cal, and I'm going to teach you how to do that. Yeah. You basically fill the hole. So what has happened here is we've broken it at 1/2. You have to pretend like you didn't break it and figure out what the y value is there. And then you can a lot of times tell where it's called a... Come to me next year. I'll teach you. I will teach you. All right, here's example 4. It's a good question. That's a good question. Man, I wish I had time for that. All right, so here we have a radical function. F of x is equal to the square root of 7 minus x. This is a square root function, okay? This is an even root. In this case, it's a square root. We looked at the square root functions when y'all took your toolkit function quiz, and you know that it looks like this. and there was a boundary that it could not go beyond. That is x equals 0. But the reason for that is because it's an even root. And what can I not do when I'm taking even roots? I can't take the even root of a, say it louder, you're right. Can't take the even root of a negative number. We remember when we studied this, okay, so like pretend like this. Let it be the square root of negative 25. This is where we had complex I, 5i. Y'all not remember this? Yeah, because there's no root. There's no pair of two numbers that are exactly the same that are going to yield a negative radicand. It's not going to happen, right? I could do 5 times 5 and I get positive 25. Negative 5 times negative 5 and I still get positive 25. So I cannot take the even root of a negative number. So the way we figure out, that's the restriction, okay? It's not going to happen. Cannot take the even root of a negative number. So the way that we find the domain on an even root is we say this, the radicand, has got to be positive. Are you with me? This business inside the radical sign needs to be positive. So I set it up as being greater than or equal to what number? What makes it positive? 7 minus x has got to be greater than or equal to
Negative
0.
0.
That value, that number underneath the radical sign, has got to be greater than or equal to 0. That's how I know that I'm not going to end up taking the root of a negative number. Because if I let that number be anything less than 0, now it's negative. Are y'all seeing what we're saying? We're protecting the stuff under the root sign. And we're making sure that that stuff stays positive. So we're taking it and we're setting it greater than 0. Numbers greater than 0 are positive. Numbers less than 0 are negative. So if I take the radicand and I put it greater than or equal to 0 and solve for x, then I will know what x can be. Yes? About 2 of you are paying attention today. Yes, yes, yes. Okay, so solve it. Solve it for x. What are we going to do here? Well, 7 minus x.
Where do you get the 4?
It's 7 numbers.
So subtract 7 from both sides. So negative x is greater than or equal to negative 7. And then what? Divide by negative 1. And we're really careful now to do what?
Flip the sign.
Flip the sign. There he is. He came to school today. Divided by negative. We flip that sign. So x must be less than or equal to 7. That's the restriction on the domain. So what is the domain of this function?
L.
It goes from what to 7? X is less than or equal to 7. Negative infinity to 7. Can it touch 7?
Yes.
Or equal to? So square bracket on 7.
I got one answer correct. Flip the sign.
Couldn't you just look at the
Alright.
7 minus x and realize that if it's bigger than x, then it would be negative and get that from it?
That's exactly what we did. Yeah.
Or not even do this, just look at,
If x is greater than or equal to 7, it falls in a hole.
yeah.
Yes, agreed. Okay, we'll stop there. We'll pick up tomorrow. Your homework 3.2 part 1. We will have to finish this lesson before you can do that. So don't do homework tonight.